Good day all of you. Today's gate question is two linear time invariant systems with transfer functions g1 of s is equal to 10 by s square plus s plus 1 and g2 of s is equal to 10 by s square plus s root 10 plus 10 have unit step responses y1 of t and y2 of t respectively. Which of the following statements is or are true? The first is y1 of t and y2 of t have the same percentage peak overshoot. y1 of t and y2 of t have the same steady state value. y1 of t and y2 of t have the same damped frequency of oscillations. y1 of t and y2 of t have the same 2% settling time. Okay. So now to answer this question, which of the following statements is or are true, you have to find four things for the given g1 of s and g2 of s. Okay, the four things are percentage peak overshoot, steady state value and damped frequency of oscillations and 2% settling time. Okay, so let us start the solution. So first you consider g1 of s, that is 10 by s square plus s plus 1. Okay, what is the characteristic equation? Denominator is equal to 0 is the characteristic equation. Characteristic equation is s square plus s plus 1 is equal to 0. What is the actual characteristic equation? General characteristic equation. General characteristic equation s square plus 2 delta omega n s plus omega n square is equal to 0. Now you compare these two. Okay, if you compare these two, what is your omega n square? Omega n square is 1. So implies your omega n is 1 and 2 delta omega n is equal to delta omega n is equal to again 1. It implies what is delta? 1 by 2 omega n, that is 1 by 2, which is 0.5. Then the 2% settling time is Ts is equal to 4 by delta omega n, that is 4 by 0.5 into 1. So that is your 8 seconds. And next, damped frequency of oscillations omega d is equal to omega n into root 1 minus delta square. So that is equal to for these values omega n is 1 into root 1 minus 0.5 whole square. So the answer is 0.866 and steady state value ESS is equal to, the steady state value is limit s tends to 0 g1 of s, that is 10 by s square plus s plus 1. So the answer is 10. Okay. Yes, now consider the second case g2 of s, that is 10 by s square plus s into root 10 plus 10. Now compare this with this expression. Compare the characteristic equation s square plus s into root 10 plus 10 is equal to 0. So omega n square is equal to 10 implies omega n is equal to root 10. And next 2 delta omega n is equal to, yes, it is root 10, implies delta is equal to root 10 by 2 omega n. root 10 by 2 into root 10, that is 0.5. Then your 2% settling time Ts is equal to 4 by delta omega n, 4 by 0.5 into root 10. That is 2.535. Your damped frequency of oscillations omega d equal to omega n into root 1 minus delta square. Omega n is root 10 into root 1 minus delta is 0.5 whole square. That is 2.739. And the steady state value ESS is 1. Okay. So now if you compare this case and this case carefully, percentage peak overshoot, this is the first option. What is the percentage peak overshoot? Percentage MP formula. E power minus pi delta by root 1 minus delta square into 100. This is your percentage peak overshoot. So if you observe, here it consists of only the variable delta. If you observe the deltas, delta for this case is 0.5 and delta for this case is also 0.5. So what will happen? As the two deltas are same, two percentage peak overshoots are also same. Okay. So you can say option A is correct. Next, same steady state value. What is the steady state value here? Here it is 10, here it is 1. So not correct. And same damped frequency of oscillations means omega d. Here omega d is 0.866. Here omega d is 2.739. So it is also wrong. Next have same 2% settling time. Here it is 8 seconds. Here it is 2.535 seconds. So this is also not correct. So the answer is only option A. So as totally 100 videos are completed, I am halting this gate for today for this year. Thank you for your wonderful support.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.